Hello, so for the last two sections, we've been looking at different types of transformations, and today we'll be putting all those transformations together. So to start, multiple transformations can be applied to a function using the general transformation model. So the equation would look something like this. Y equals to A f b x minus h plus k. And we're just going to refresh our memories on these different letters and what they mean. So A is vertical stretch, so that includes compressions and expansions, and also vertical reflection. B is horizontal stretch and horizontal reflection. H is horizontal translation, and K is vertical translation. One thing you have to be careful about now that all these transformations are being combined is that order matters. I'm writing it in red with 3 exclamation marks because it's very important. So the order is that first comes stretch and reflections, then comes translations, okay? Oops. Translations. So one way to help you remember that is just to go alphabetical order when it comes to your transformations. So start with A, then B, then H, then K. Since you have to deal with stretches and reflections first, technically A and B could be interchangeable, so these two could be switched around. H and K, since they're both translations, could also be switched around. But just to make your life easy, just keep it in alphabetical order. Okay. Something else you have to be careful about is this B right here. I'm going to write this in capitals because students always forget this one. Factor out. So make sure you factor out that B. And what I mean by this is, for example, if there's a function where you have f5x plus 10, at first glance, you might think, okay, I have b, which is 5, and that 10, that's where it's going to get confusing. It's, hey, it looks like I need to horizontally translate 10 to the left. But no, you need a factor. So if you factor out that 5, you'll see that, in fact, that horizontal translation is actually 2 to the left and not 10. So you can see how big of a difference that would make if you didn't factor. Moving on. So now that you have all these different transformations together, mapping will be a little different because now we need to make sure we incorporate all 4 transformations. So again, you start with the original xy. Remember, the x value is affected horizontally. So that means B and H is going to be affecting X, and B specifically is always the reciprocal. It's always the reciprocal of B that is multiplied to X. You always need to flip it for that horizontal stretch. So it's going to be X divided by B plus H, and that Y value will be A times Y plus K. So let's look at this in an example. So here we have describe. Ooh, remember this word? Describe. What do we mean by that? We mean words. Oh, actually, before we continue, missed one thing. So when it comes to these transformations, we're going to be using them a lot. And to write down all these words every time may be a lot for some of you. So I will be accepting you to, if you choose to, kind of shorten it. So vertical stretch could be VS, vertical reflection could be VR, etc. So horizontal stretch is HS. Horizontal reflection is HR. Horizontal translation is HT. And vertical translation could be VT. I'll take that. Okay. All right, back to our example. Okay, so describe using words, or I guess the letters will do too. The combinations of transformations that must be applied to the function y equals to fx to obtain the transformed function. Sketch the graph. So our original graph is going to be a parabola. And we need to graph this transformed function here. So let's just look at what transformations we're looking at. So we first have this 2. This is basically our a. And we have this -3. You need to take the minus sign too. And this is going to be our k. So writing down our transformations, A, remember, is dealing with vertical stretch. Actually, I'll just write that out. So A is 2, which means I'm looking at a vertical stretch by factor of 2. And I have k equals to -3, which means I have vertical translation down 3. So one way to do it, I'm just going to sketch out that original. So I'm going to sketch out the original in black. Maybe put a black circle around it. So parabola is just 1, 1, 2, 4, 3, 9. You should be very comfortable graphing this now. If you're not, make sure you get very comfortable with it within the next few sections. Okay, so that's our parabola. A little shaky, but that'll do. And I'm just going to go with the mapping method to figure out this one here. So our original points are xy. And from here, x is affected by b and h, both of which are not present. So x will just be as is, but y got multiplied by 2 and -3. So from our parabola, our key points include 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. So from there, we're just going to plot our new transformed points. I'm just going to start by writing down the x values because that has not changed at all. 0 is now down at -3. 1 is now at -1 for both of them. And 4 is now at 5. So now that we got our 5 points, let's move it. So we're at 0, -3, 1, 1, and 2, 5. And here we're gonna, again, just round it. Trying to draw the best, oh, a little shaky there. And up we go. Okay, so that blue graph there is our transformed function. Okay. So here we have another graph. Again, our base function is going to be a parabola, but our transformed function has different transformations this time. Now, before we start, here is something I mentioned before. We need to factor. Because as you can see right now, there isn't that second set of brackets there. So this will actually be f half, take out that factor, that half, x minus 4. Now we can start analyzing the different transformations. So this here is b and this here is h. So let's first start by describing our transformations. So we have B, which is half. Now with horizontal stretches, we always need to deal with the reciprocal when we're actually talking about the transformation. So this is actually horizontal stretch by factor of 2. So you're actually expanding, even though B is half. And H, remember, with horizontal translation, you need to take the opposite. So H is actually 4. And we're dealing with a horizontal translation. Don't know why I'm writing by. Right 4. So let's put this into our mapping. So we have X, Y, and in this case, since it's B and H, so X is actually being affected. So we have X is divided by B, which is half, plus H. And Y, well, nothing's affecting vertically, so Y is just going to stay as is. So before I plot in the points, reminder, parabola, key points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, oops, 3, 9, negative 3, 9. You should know this. If you don't, practice. Hopefully you don't have to do a table of values anymore. And you already know at least these points by heart. Okay, so let's do our mapping. So we have our 0, 0. Oops, that's not a 6, that's a 0. Let's fix that up. 0. 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay. Let's write these down. So X divided by half, you know, when you divide by a fraction, you could just multiply it. So I'm just going to tell you it's basically just 2x, okay? So here we have 4, 0. And then next we have 6, 0. Next we have 2, 0. Oops, wait, why am I writing 0? These are 1, 1, 1. And then we have 8, 4. And then here is 0, 4. So now we can plot in our points. So we have 4, 0, 6, 1, 2, 1, 8, 4, 0, oops, 8, 4, 0, 4. And then we'll just connect our points together. Okay, and you can, well, you can see that it's just going up 1, 1, 4. So the next one will be at 9. It'll be probably out here, like so. 9 here. Okay. All right, and that's your graph. Okay, moving on to the next one. Okay, so this time we're dealing with more transformations because so far for the last 2 examples there was only 2. So describe the combination of the transformations that should be applied to the function fx equals to x squared in order to obtain the transformed function. Okay. So before we start describing, we need to look, do we need to do something that starts with an F? Factor. Factor, maybe? Yes, we do. So let's take out the question mark. So let's do that first. So negative 2, F, half, X, this time it's 8, plus 3. Okay, so in this particular case, here again is our A, B, H, K. Time to describe the different transformations. Describe, use your own words. So let's start with A. Well, let's start with the negative sign. We actually have a vertical reflection. And then with the 2, it's actually a vertical stretch. by factor of 2. And then next we have b, which is a half. Remember, you need to find the reciprocal, so it's horizontal stretch by factor of 2. 8 is horizontal translation. Plus 8, remember to take the other opposite, so it's left 8. And k is a vertical translation, 3 up. So these are the different transformations. We're good. Okay, time to graph this thing. So again, I'm just going to graph that base function. I think we're graphing a parabola for the third time. Here we go. Here's the parabola. The key points do need to be in the right spot though. Okay, so if you kind of just do a, if you just do a really messy one like this, that's no good. Okay. All right. So with our, let me just scroll up a little bit so I can see. So let's just start with our mapping. So x is the horizontal stuff. That's this part. So horizontal by factor of 2. So it's basically 2x, or x divided by half, left 8 minus 8. For the vertical stuff, there is a reflection. So remember with a, it's negative 2y, and then 3 up plus 3. This is our mapping. Let's put in our key points. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So first we have negative 8, 3. Next we have negative 6, 1. Here is negative 2, so it's negative 10, 1. And then here we have negative 4, negative 5. And finally, the last one here is negative 12, negative 5. Okay. So let's plot these points down. So first we have negative 8, 3. Then we have negative 6, 1. 1, 2, 3, 4, 5, 6, 6, 1, 10, 1. Negative 4, negative 5. Let's see, here's 4, negative 5. Okay, well, negative 12 is off the charts, so can't really graph that guy down. Okay, so it's going to look something like that. And there we go, our transformed graph. All right. Last one of the day here. This one's kind of small. Let's zoom in. So the graph of the function y equals to gx represents a transformation of the graph y equals to fx. Yes, it's another parabola if you haven't noticed. So state the equation of the transformed function. Explain your answer. So far, we've always been given the equation and we just draw it. So now we're given a transformed graph and we need to come up with the equation. Now, when we're solving this, we need to be mindful that with transformations, there is that order, right? So you always need to deal with, you always need to look at stretches first, stretches and reflections first, and then translations. So I know it's very tempting to immediately say, hey, you know, let's look at move here and then move down and then start stretching it from there, but we want to avoid that. So when it comes to parabola, we know 0, 0, regardless of how you stretch it or reflect it, it's going to be in the same spot. So we can take that kind of as a reference point. And then from there, we know there's these two other key points, the 1, 1 and negative 1, 1. that we can compare with the graph in red. One transformation that's already really obvious is that, well, it flipped upside down. So we know there is a vertical reflection. That we know already. So that means there's going to be a negative sign. Now next, here's where we need to start to compare. So it used to be, when we compare these two, the width for these two key points used to be 2, and the height was just 1. And now we're looking at a width of 4 and a height of 3. So from there, first looking at our vertical, since A is vertical stretch, from 1 to 3, it's 3 times, right? So therefore, we know our vertical stretch is by factor of 3, because we're going from a vertical height of 1 to a vertical height of 3. To get from 1 to 3, vertical stretches always multiply, so it's going to be 3. And for our horizontal stretch, as we can see, we went from a width of 2 to 4. And to get from 2 to 4, again, it's going to be multiplied. Therefore, we know it's by factor of 2. Now that we've done all our stretches, now we can deal with the translation. So once you've stretched it from here, yes, it does move 3 to the right, and then, oh, not 3, sorry. No. And then from there, it does move 4 down. So therefore, we also have let's start with the horizontal first because that's H. So horizontal translation, right 3, and we have vertical translation down 4. So now that we have these points, let's just put them all into the equation. So vertical reflection's a negative sign. I'm not going to write that down. That means we know A is equal to 3. B is going to be half. Remember, you need to take the reciprocal. H is 3. And K is down 4, so negative 4. Putting that into our equation, so Y equals to vertical reflection, negative 3. Oh, wait. And then we have our F. B is half, bracket, X minus H, and then our K. Here's our equation. And that's it for today.